considered by IT teams when seeking to create a layered security environment. First is people. Employees can create some of the greatest risks to cybersecurity. When they are well informed, however, they can also be an asset in the first line of defense. Second is processes. This layer of cybersecurity ensures that IT teams have strategies in place to proactively prevent and to respond quickly and effectively in the event of a cybersecurity incident. And third is technology. There are hosts of technologies that security teams can implement to layer their defenses. It is important that IT teams do not implement isolated point solutions, as they layer their defenses, but rather select those tools based on their ability to be integrated and automated to create a security fabric that can facilitate the rapid detection and mitigation of threats. Emerging technologies in cybersecurity. Hardware authentication is a well-known fact that a majority of data users' passwords and usernames are weak. This makes it easy for hackers to get access to the information systems and compromise sensitive data of a business entity or government agency. This has also exerted pressure on experts of systems security to come up with more secure authentication methods. One of the ways is the development of user hardware authentication. Hardware authentication can be especially important when it comes to the Internet of Things, where the network of connected devices ensures that any device that seeks to be connected has the rights for connectivity to that particular network. Cloud technology is set to have a significant impact on the transformation of systems security technology. More business enterprises and government agencies have embraced cloud technology to store the vast amounts of information that they generate daily. Deep learning encompasses some technologies like machine learning and artificial intelligence. There is a significant deal of interest for systems security in these technologies. Deep learning, just like behavior analytics, focuses on anomalous behavior. Whenever artificial intelligence and machine learning systems are fed with the right data regarding potential systems security threats, they can make decisions on how to prevent hacks depending on their immediate environment without any human point. 5 types of cybersecurity. Critical infrastructure security consists of the cyber-physical systems that modern societies rely on. Examples are electricity grid, water purification, traffic lights, shopping centers, and hospitals. Application security is more accessible over networks, causing the adoption of security measures during the development phase to be an imperative phase of the project. Examples are antivirus programs, firewalls, and encryption. Network security ensures that internal networks are secured by protecting the infrastructure and inhibiting access to it. Examples are extra logins, new passwords, and application security. Cloud security is a software-based security tool that protects and monitors data in cloud resources. Cloud providers are constantly creating and implementing new security tools to help enterprise users better secure their data. Examples are software as a service, infrastructure as a service, private, on-site cloud, and virtualization. Internet of Things security refers to a wide variety of critical and non-critical cyber-physical systems like appliances, sensors, televisions, Wi-Fi routers, printers, and security cameras. What is a security policy? A security policy is a set of rules that applies to activities for the computer and communications resources that belong to an organization. These rules include areas such as physical security, personnel security, administrative security, and network security. The security policy defines what an organization wants to protect, and what it expects of its system users. It provides a basis for security planning when designing new applications, or expanding the current network. It describes user responsibilities, like protecting confidential information and creating non-trivial passwords. The security policy should also describe how the effectiveness of security measures will be monitored. Such monitoring helps in determining whether someone is attempting to circumvent the safeguards. When creating and carrying out a security policy, one must have clear objectives. These objectives must fall into one or more of the following categories. The resource protection scheme ensures that only authorized users can access objects on the system. The ability to secure all types of system resources is a system strength. As such, carefully define the different categories of users that can access the system. In addition, define what access authorization can be given to these groups of users as part of creating security policy. Non-repudiation is the proof that a transaction occurred, or that a user sent or received a message. The use of digital certificates and public key cryptography to sign transactions, messages, and documents support non-repudiation. Both the sender and the receiver agree that the exchange takes place. The digital signature on the data provides the necessary proof. Auditing security activities monitor security-relevant events, to provide a log of both successful and unsuccessful access. Successful access records tell who is doing what on the systems. Unsuccessful access records tell either that someone is attempting to break the security, or that someone is having difficulty accessing the system. Authorization. This is an assurance that the person or computer at the other end of the session has permission to carry out the request. Authorization is the process of determining who or what can access the system resources or perform certain activities on a system. Typically, authorization is performed in context application. Confidentiality. This is the assurance that sensitive information remains private and is not visible to an eavesdropper. Confidentiality is critical to total data security. Integrity. This is an assurance that the arriving information is the same as what was sent out. Understanding integrity requires understanding the concepts of data integrity and system integrity. Authentication. The assurance or verification that the resource, human or machine at the other end of the session really is what it claims to be. Solid authentication defends a system against the security risk of impersonation, in which a sender or receiver uses a false identity to access a system.